The last example I want to look at is x to the 2/5 equals 2. I want to be able to solve this equation for x. Issue here, I have x raised to the 2/5 powers. And what we've been talking about in class is that we'd try to make this exponent 1, right? So if I raise both sides to the 5/2 power, when I multiply 2/5 and 5/2, I'm going to be left with an x, so I get x to the first power, and my right hand side is going to be 2 to the 5/2, right? And so what I want to do now is I want to simplify that, right? Well, we know that this is the index, and this is like the exponent if we want to write it in radical notation. So I could write this as the square root of 2 to the 5th, which we can see that that's the square root of 32. And if I wanted to simplify that, square root of 32 is 16 times 2, because 16 is the largest perfect square that goes evenly into 32. And I can take the square root of 16 and I get 4. So I get 4 times the square root of 2. Okay? Now, one of the things that happens when we have these types of equations here is that when I just raise both sides to a power, I'm only going to see one possible solution, and that's the positive solution. All right. Another possible solution is -4 times the square root of 2 or the square root of 32. All right. And this is something that we didn't really discuss in class, but if I've got to consider both in order for me to get all the possible solutions to this equation. All right. If I just raise both sides to the 5/2 power, I'm only going to be left with one solution. That's one possible solution. And one of the things is because that this thing right here is squared, I can have another possible solution that this method is not going to give me. All right, and so what I'm going to do is I'm going to check these two possible solutions. Okay. Now, one of the things that makes it difficult is that when we have it in, I'm going to check plus or minus 4 square root of 2. When I have it written in this form and I'm going to raise something to like a 2/5 power to check it, it's going to make things a little bit harder to look at. And so I'm going to change it back to the square root of 32. And I'm going to check to see if the plus or minus square root of 32 are my solutions. And so I'm going to go back to my original equation, square root of 32 to the 2/5. I want to see if that equals 2. And so what I'm going to do first is I am going to square it, because remember this numerator is an exponent. So if I square the square root of 32, I get 32. Then I raise that to the 1/5 power. We're going to see if that equals 2. And then 32 to the 1/5 power is the same thing as doing the 5th root of 32. And we know that the 5th root of 32 is 2, because 2 to the 5th power is 32. All right, I'm going to do the same thing for negative square root of 32. So I'm going to put negative square root of 32 in there, raise it to the 2/5 power, and see if that equals 2, right? That's the question I want to answer. Well, if you notice, when I square this negative, it becomes positive, and when I square this square root, it becomes a 32, right? So this is still going to be a positive 32 to the 1/5 power equals 2, and this is basically what we did over here, so I know that checks out as well. So I have two solutions. One is -4 square root of 2, and the other is 4 square root of 2. We always want to write our solutions in the simplest form, but I check by using this method here because it's easier for me to see when I check my solution that that is the solution.